In this video, we're going to be taking a look at example 3, which is on the double angle identities notes, since we didn't get to that in class. So we're going to be starting with this one, and then in separate videos we'll do problems 4 and 5. So we've already done problems 1 and 2 in class. All right, so we have the formulas up here at the top for the double angle identities. I have those written in because we're going to be using those. And I want you to notice that these two problems that we did in class, the way that these problems were set up was you were given the sine of A or the cosine of A. Here we have the sine of A. And you were asked to find the sine of 2A and the cosine of 2A. So you were given the kind of single angle problem. You were given, so sine of just A, and you were asked for the double angle, 2A, or cosine of 2A. Same thing here, sine of 2A, tangent of 2A. This is the opposite, all right? This one you're given the cosine of the double angle, and you're asked for the cosine and the sine of the single angle. So we're still going to be using the formulas that we have up here, but we're sort of using them backwards is what's going to happen. So for A, what we would like to have is some kind of a formula that has cosine of 2A in it and cosine of A. So if we go back up here, we can see here's the one that's the cosine of the double angle. And then if we want one that only has cosine in it, because that's what we're asked to find, then we would want to use this formula right here. So we're going to start with this formula, that the cosine, and I'm going to write it in terms of alpha. So the cosine of 2 alpha is going to be 2 cosine squared alpha minus 1. Right, and now what we know, we don't know what this is right here, right, like we did before, but we do know what this is. The cosine of 2 alpha is 3/4. So this is going to go in this side. So this is a little bit backwards. So we're going to have 3/4 is equal to 2 cosine squared alpha minus 1. And we want to solve for cosine alpha. So the rest is just algebra, all right? So I need to get this cosine alpha all by itself. So I'm going to add 1 to both sides. I'm going to add 1 over here, but I'm going to add it in the form of 4/4. And so I end up with, when I add this, 7/4 is equal to 2 cosine squared alpha. Now I want to get rid of that 2, so I'm going to multiply both sides by 1/2. So this gives me just 1, and so I get 7/8 is equal to cosine squared alpha. Right, now I want to take the square root of both sides, and I want to point out here that alpha is acute. So if alpha is acute, it means it's between 0 and 90. It means it's in the first quadrant. So remember that all the trig ratios will be positive. So when I take the square root, usually I have to think about the positive and the negative square root, but in this case I only care about the positive square root. So I end up with the square root of cosine squared is just going to be cosine alpha. And then over here, I just end up with the square root of 7/8, but the square root of 7/8 is the square root of 7 over the square root of 8. And then it's just a matter of simplifying that and noticing that this is the same as 7, square root of 7, sorry. And then this is 2 times the square root of 2, because this is the square root of 4 times the square root of 2. So this ends up with 2 times the square root of 2. And then if I want to rationalize the denominator, multiply top and bottom by the square root of 2, you get the square root of 14 over 4, because this is 2 times 2, so that gives me 4. So that's your final answer for that one. Now, for the sine of alpha, if I want that one, again, I know the cosine of 2 alpha, I want the sine of alpha. So what we can do now is go back and find the formula that contains both of those. So if I go back here, here's the cosine of 2 alpha, so I'm only selecting from these formulas, but this is the one that I want this time because this one has the sine in it. So I'm going to, I don't know why this keeps freezing. So I'm going to come down here and I'm going to use the formula that the cosine of 2 alpha is equal to 1 minus 2 sine squared alpha. Then again, I'm going to sub in what I know. So I know that the cosine of 2 alpha is 3/4. So I end up with 3/4 is equal to 1 minus 2 sine squared alpha. And then again, it's just a matter of doing some algebra. I need to get this sine alpha all by itself. So I'm going to subtract 1 from both sides first. Over here I'm going to subtract 1 in the form of 4/4. So I end up with negative 1/4 is equal to, now be careful, this goes away, but I still have negative 2 sine squared alpha. I want to get rid of that negative 2, sorry, so I'm going to multiply both sides by negative 1/2. And so I end up on this side, this all cancels, so I get sine squared alpha is equal to, and then this is 1/8. And then once again, I'm going to take the square root of both sides. And because the angle is in the first quadrant, I know the sign is positive, so I don't worry about the plus or minus because it's just going to be plus. And so we end up with sine alpha is equal to, now it's the square root of 1/8, but that's the square root of 1 over the square root of 8, which becomes 1 over 2 times the square root of 2, just like it did over here. And then I'm going to rationalize the denominator by multiplying by the square root of 2, and so I end up with the square root of 2 over 4. That's what that should end up to be. And that's the final answer for that one. Now, I will point out that there is another way that you can find the sine of alpha, because if I know the cosine of alpha, which I do right here, then I can use the Pythagorean identity. Let's squeeze up here. So we know that sine squared theta plus cosine squared theta is equal to 1. And so if I know that the cosine from down here is the square root of 14 over 4, then this would become that sine squared theta, well, alpha, if I use alpha, plus the square root of 14 over 4, square root of 14 over 4 squared is equal to 1. So this becomes sine squared alpha, plus when I square this, I get 14 over 16 is equal to 1. And so I'm going to end up with, when I subtract the 14/16 from both sides, I end up with sine squared alpha is equal to, this is 16/16. So this becomes 2/16, which is the same as 1/8. And then I want you to notice that what happens is the same thing that we had here. We're at the same place, right? Sine squared alpha equals 1/8. We were here for this one also. All right, that finishes that problem. We'll do separate videos for the other two.